Welcome to another very exciting session of healthcare entrepreneurship. So, today we are going to talk about where we left in the last class and go from there. Okay. So, let us get started. FDM typically has PLA and ABS, and you have flexible materials also. There are quite a few brands which will print you like a material known as TPU, thermoelastic uh, thermoplastic like basically polymers, so TPU, and then polyurethane like thermoplastic polyurethane, and then you have TPE, right, thermoplastic elastomer. So, there are several other materials which you can see which are highly flexible and can be used in FDM these days, and quite honestly, with the latest trend of things, I find FDM to be much more successful in terms of creating materials and how many options you typically have, right. So, SLA is usually much less successful in terms of how many people use it. They are, but having said that, they still provide a very high quality, and if you are looking for quality, go for an SLA. In terms of performance and ease of use, SLAs have an extremely high repeatability, but not very easy to use. So, if you use an SLA printing, you will never have to complain about the high precision, right. It is just like you are printing on a piece of paper, like you have a normal printer in your house, right, every time consistent. So, even after 200 prints, very consistent, but not very easy to use. You need a lot of complexities and design understanding. If something has gone wrong, you need to take out the entire material, probably clean some materials out. So, maintenance is also very difficult. FDMs in the other cases are very high maintenance. SLAs are high maintenance in the terms you need to know exactly how to maintain it, but FDMs are typically which will go bad after 2 prints, and we have seen it. I have close to 35 to 40 FDM printers in my lab currently at IIT Delhi, and we work with several manufacturing things, and we have put 2 dedicated persons who are just into maintenance. So, after every 2 or 3 prints something goes bad, either the bed leveling goes bad, or there is an extrusion issue, or the quality is not coming out due to n number of other reasons. So, they are there to fix it from time to time, otherwise things cannot move on. So, if you are an entrepreneur who is trying to have very few skilled people, and you are trying to use 3D printing for manufacturing, let us say 15 or 20 models, then you may be fine with an FDM, but if you are looking for more numbers, you need a skilled person to maintain it, right. SLA is typically when you just need one model to pitch to the highest bidding investor, and you think that this high quality model will impress this so much that you could get the highest amount of funding for your product, right. So, SLA is very nice and soothing to the eyes, as can be seen from the pictures. Typically what you can compare it with, just look at the high resolution. So, bottom picture, high resolution versus low resolution. FDM can be compared with a low resolution image of a high resolution image, right. So, we have all kind of come across through different generations in which we have seen the image quality drastically improve in our mobile phones, in the cameras. So, we know what high and low resolutions are, like 480p, right, like very low resolution. If you play a movie in that or any kind of video in that, it is very poor quality. But if you go for 1080, 760 and so forth, you get a very high quality, right. So, that is a very similar thing. SLA is high quality, FDM is low quality typically. From the cost and build volume standpoint, you have it attracts a very high amount of cost to buy a SLA. I have put it as 1 lakh to crores. This has been a while. SLAs now come at 50,000, 60,000 as well, but they are not very good quality. I would recommend going for a 80 or 90,000 plus SLA printer if you would like to go for. And of course, like I have said, do not go for the price only, go for the key specs and focus on them, and then go for the price and see what's within your budget, right. They would typically offer a very low build volume. This is something to consider. If you are trying to print something as big as this particular coffee mug or coffee glass, then SLA may still work, but a little beyond this you will not be able to print, and some of the SLA printers will not be able to print this size. So the sizing amount is very, very low. So you might have to scale down certain models to showcase using an SLA printer. Very limited size is being offered because it is a very slow process and very, very high quality. Whereas in FDM I have shown you, like, it can go up till 2 meters and so forth, human scale, vehicle scale, ship scale, like all the different scales you can go to using the FDM technology. There has been like news around where they have printed an entire house with a fused deposition molding technique, right? FDM 3D printing. Just look up 3D printed houses. This will just really surprise you. It has been done in India also recently, and there are several countries in Europe where they have completely 3D printed a house, not with a filament material, but with some kind of cement and other mixtures, where they have used 3D printing technology to build a house like that by not putting too much of pillars and other things like around it, right? So FDM can have a very large bandwidth, but SLA usually has a much lesser build volume. It is for very high quality, high precision parts. So dental implants, which are fairly small, are typically done by SLA printing, right? Maybe some kind of very small implants which you place in the eyes, or are kind of going in different biosensors and other casings, those things you can print on an SLA. Very high precision, valves and catheters and like other specific technical prototypes, like of several devices, incision or surgical devices which you use in the medical industry. Those things can be built on an SLA very quickly, right? Let's go further. So next we talk about subtractive manufacturing or 3D cutting, right? So this is what subtractive manufacturing can be summarized into. So what are the key 3D cutting technologies? So subtractive manufacturing, typically also known as CNC machining sometimes. It is not the most appropriate term, but CNC is kind of synonymous to subtractive manufacturing, is a machining process in which solid piece of raw material is carved into a desired 3D geometrical shape and size by using a controlled material removal process. This is the definition of a subtractive manufacturing technique. Controlled material removal process is basically used to cut out material from a particular block of material, right? And then within this cutout, like, you finally get the product. Very classic example of subtractive manufacturing is the hip implant. I have talked about this very classic hip implant, which is based on, if you have a hip failure due to some kind of accident, then femoral bone is cut through, you place a hip implant, ball and socket joint is kind of sync together, and surgically if a hip implant is placed. Typically it is a blob of single material, it is basically one single material, and you can basically cut them out using CNC machining or using subtractive manufacturing. It is a very common technology. Many of the stents are built using subtractive manufacturing. Stents which go into the clogged arteries to remove, to get rid of blood clots, or to have a better path for movement of blood and whatnot. Majority of the medical devices which you see in the market, drug delivery based devices, are using subtractive manufacturing. They are not using additive manufacturing. Additive manufacturing is typically very well known for prototypes, but for actual device manufacturing, majorly subtractive techniques have been around for time and ago, right? Like, they have been around for decades, and that's typically what is being used. Subtractive manufacturing relies heavily upon the use of machine tools in addition to power and hand tools. So there are several machine tools as well as manual tools as well. Typical processes which are part of subtractive manufacturing, including cutting, abrasive processes to make sure the surfaces are finished to certain levels of need, and advanced machining processes where certain notches, holes, curvatures, certain high surface points and other details are needed in the particular product. So, whenever you are in the medical device industry or you are looking at implants, prosthetics, you are talking about subtractive manufacturing as the key technology to build your products, right. You are looking at prototypes like wearable technology, smart watches, and nice implant design to just take a look at additive manufacturing, right. Let us move further. So, what are the three different 3D cutting machines which are there in the market, which are very popular, and some of the techniques we would like to highlight here. The first one is known as a lathe machine. Many of us may have seen a lathe machine if we are part of some engineering group or we have studied engineering. We would have seen this in a machine shop. Lathe machine is basically has a bunch of gears and a bunch of mechanisms. It basically has a moving round moving kind of motor in which you fix a job, you call it a job or a base material. So, it is basically a cylindrical form of material which keeps on rotating, and there is a cutting tool. So, this is how the material is coming out. It's kind of rotated like this, and you have a cutting tool, it keeps on rotating, and this cutting tool keeps on taking out material from here. So, you can reduce the diameter of this particular cylinder or cut certain slots and other shapes within that in several segments. So, typically a lathe machine is used for producing gears, round parts, something which has a round edge or sub assemblies, various types of valves, fitments, and components of medical devices. So, these are lathe machine is very widely used, and this was typically used in the industry for mechanical engineers, originally used for automotives, heavy industry parts, big machinery parts. Lots of screws and other very precision valves are built on lathe machine, but these days lot of these medical devices can also be built. So, this is basically you have to remember this operation. Lathe machine is something which is a rotary motion, and you have a cylindrical kind of component which is basically rotating. You can put it here and there where exactly, and there is a cutting tool which basically keeps on cutting as it rotates. So, it cuts a slot and other details, right. This can create a convergence, create certain surface finishes and whatnot. The second component is drilling. So, first is lathing, second is drilling. Drilling, as we all know, we have heard the term drilling. Drilling means putting a hole into something, right, typically. So, this is how a pillar type drilling machine typically looks like. You have basically a drill chuck which holds the drill. There is a drill bit. Drill bit is basically defined by what is the diameter of the hole or what is the size of the hole which you want, and how big of a hole you can particularly want, right. So, then you have a table which is a platform. On that you place a material and you place the drill, it creates the hole. You can create multiple holes, and usually there is an electric motor which makes sure the drill is rotating, and you can put there is a arm based system like which is a powered hand wheel to raise and drop the drill, right. While this is rotating, this is you place the arm on the wheel to bring it down, and basically it cuts the hole through the particular material. Can you use any material here? Can you use plastics, metals, anything? So, there are certain materials which it cannot work with. So, if you have a very high grade of steel or iron, the drill machine may break in an iron platform. So, there are only ways built for soft or medium grade materials. So, some forms of steels can be used, you can use aluminum, you can use polymers, and so many other things can be drilled. And there are separate drilling speeds for these particular materials. So, if you are going at a very low speed, you will be able to work with very soft materials, but for much more harder materials you want to go at a high speed. High speed basically allows you to cut through very quickly, right. So, this is as far as drilling is concerned. Then you have a milling machine, which is a very classic machine which has the option of also drilling. But the purpose of milling is a little different. Milling basically has a drill chuck again, which is known as a spindle, and within that you have a cutter which is very similar to a drill, but it is a cutting tool rather than a drill has pitch and design like which is specifically built for drawing a hole, but this is kind of has cutting or sharp edges like which can cut material out. So, a milling machine basically allows you, there is a platform, this is the stable platform where you can clamp a certain block of material and you can move it along the x and y axis, right, like this way and this way in a very high precision way. And there are several auto milling machine where you can just move it by this much coordinate, this entire thing will move it by this much coordinate. And then there is a stop drill or cutting mechanism where you can place your hand, and this is different speeds of cutting material, and then this drill or cutter basically comes down and keeps on taking out material. And as it does that, you can fix it where it is kind of cutting the depth of the cut. So, let us say you have a depth of 3 millimeters for the cut, and you can keep on parallelly moving the material, the block of material around to make sure it is properly cut. An entire layer can be cut out and layer by layer you can keep on cutting, right. So, you typically get very high precision parts like some of the components shown here on the very right bottom. So, you are looking at some particular joints. Many of these joints are used in prosthetics, like many of the prosthetic limbs are using certain joints. Many of the orthotics and other prosthetics are also using these kind of joints, and along with that these are highly applicable. These manufacturing technologies techniques are majorly not built for healthcare industry, they were actually built for mechanical engineers, but this is currently being used widely in the area of healthcare for building products, right, hardware based products. So, the 3D cutting technologies we have mentioned the lathe machining, drilling machine and the milling machine. CNC machine is typically a very complex and very highly automatic machine. It is a huge machine. It has like let us say 50 to 100 different cutting tools and drills, right. So, these kind of machines and have lots of degrees of freedoms, like lot of motors in which operations can be done. So, you have basically a job flow or a flow chart that these are the steps in which I want this much amount of material to be lathed out, this much amount of material, these many places, 10 drill points, then several parts, the layers have to be completely removed. So, all this lathe machine, drilling, milling operations can be clubbed together within a CNC machine, very expensive. So, you cannot buy a CNC machine typically if you are part of a small clinic or small manufacturing setup. You would typically see a big CNC machine in a heavy industry or a big institute, right, very in the order of crores, multi crores. So, CNC machines are typically machine tools that cut or move material as programmed on a controller. So, you have a controlling system and you have a complete program through which the machine and everything is automated, right. As described above, the type of cutting can vary from plasma cutting. So, there can be plasma cutting to laser cutting to milling, routing, lathing. There could be so many different cutting technologies all put together. So, based on the specifications which you have for a particular CNC machine, they can range from like 7 operations or 10 operations to 50 operations, different operations, and they can also move the material as they do this different operations. So, it is a mini manufacturing line, right. Typically very high cost, you are looking at a high volume of production. So, you want to take out like let us say these medical some form of implants which are going to go inside the body, let us say spinal implants, you want to make 100 of this in no time. So, there is a certain coding and different dies are cut and initial things are placed, and within no time you are getting hundreds of this particular products, right. Typically the prices for the die and doing it one time. So, if you are changing the design too much, you will have to pay a lot extra. So, this is for typically producing the same part again and again. High volume, high precision, very high precision. So, if you are looking at the different components of your car, they are majorly CNC'd, right, like all your joints of the car. Otherwise, when you are moving the steering, if your one wheel rotates a little bit more towards here, your car will go here and there. So, these are all high precision, similar with implants, right. So, CNC is one of the topmost machines there, and laser cutting is another technology where basically it uses a laser to vaporize materials resulting in a cut edge. So, laser has a very high amount of heat to which vaporizes the material, and it just completely goes away, and this is a technology of the laser cut. There are YouTube videos for both CNC machine, these are the links, and the laser cutting technology. The principle is basically the laser beam is kind of reflected by a mirror and goes through a gas nozzle and a focusing lens and completely vaporizes the material. It has a cutting gas set of gases, and the workpiece or the base material is at the bottom as in the figure on the right, and it is cutting out high precision components out of it, right. So, where are these used? These are used for several sensor development, like specific implants and particular larger size implants which have precision cuts on notches and certain channels for putting certain drugs and other details. Like there are so many other aspects like which can use laser cutting, right. We also have a laser cutter in our lab. We typically use it for building sensors, right. So, there could be so many applications, but for the medical industry, laser cutting is a nice technology, right. So, in order to summarize the different manufacturing technologies which we have learned through additive and CNC subtractive manufacturing, these are majorly for the prototype development or product development. CNC machining and 3D printing have a few basic things in common, including that they both make 3D products based on 3D models. So, both these technologies, additive and subtractive, use 3D models to build 3D products, and they are each compatible with the type of file which is .stl, stereolithographic file. So, whenever you create a design in a some software, you can export it as a .stl or .obj file, object file, and using this you can quickly do a CNC machining or 3D printing, right. So, now we are transitioning from the design phase to prototyping, where you can use these designs in particular formats like .obj or .stl and feed it to the particular devices, and they will create the manufacturing details for you, right. So, hopefully we have got some insight into the manufacturing.